and it's early, so I hear people have changed the catch, but I shall pass over to Richard for his talk.
Thank you very much. Right, okay, thanks very much indeed for inviting us today. I'm now back in what I call my homeland. Despite being a Yorkshireman, I have been migrating further north as time has gone on. I graduated from university in 1997 here, from the engineering department at Newcastle University, and hung around here for another 13 years after that. I had a very lucky experience a few years ago where I had the joy in commanding a squadron of Royal Engineers here in Newcastle, based in Heaton, and also with an outlier in Sunderland and Hartlepool. So my engineering experience is mainly mechanical materials, military civil engineering, and combat engineering. I leave the electrical engineering to colleagues. That to me is a bit of dark sort of magic, if you like. So we get them involved where my skills end. So since 1997, I've been involved in the world of forensic engineering and project consultancy in engineering and design, procurement, and conducting statutory inspections as well. I've seen everything from really good proactive best practice to some pretty interesting alternatives to that across a smorgasbord of industry. Currently involved in the mining industry, the food industry, heavy, light, medium, you name it, basically. We're involved across the board. My job with Finch is to help clients get and understand about compliance and also get their safety aspects right as well. But also I provide assistance to those who need our help on the legal stage, so from the expert witness perspective as well, which is what we don't really want to be in that situation if we can. So who are we? Finch Consulting, just a very, very quick background to it. We've got a mining background stretching back over 30 odd years. We're based in the Midlands, although we've got outlier consultants all over the UK and the Scottish office, having moved to Edinburgh 15 years ago. We've got a sister company called Tautus. Some of you will be familiar with them. We're the UK's only mine winder testing organisation, independent, and we work closely with the HSC Mines Inspectorate, and Don Barraclough, who is the manager for Finch, basically, also sits as the chair for SMIM, so the Safe Man Riding in Mines as well. So we've also got another company as well called LEAPS, which is the Leisure Equipment and Asset Protection Scheme. So again, machinery safety, but an inspection for the leisure industry, so roller coasters and things like that as well. So what I want to talk to you about is what I've classed as P to the power 12. You could argue it's P to the power 14. What is that? It's proactive planning practice promotes protection of people and profits by preventing poor procurement and poor procedures. And if you want to, you can add on to that poor process as well. So I try to simplify it by P12, and I'll reference that a little bit later as well. So what are we talking about here? So I want to start off with where Finch usually get parachuted into, and where we try and avoid it. And ideally, this is what we're trying to do at the moment. So we've been working in collaboration with the Mines Inspectorate. So some of these slides, you'll see there's a little reference there to HSE Mines Inspectorate 2023. This slide was taken from Vince Fowler, who I'm sure some of you may know. And we've been helping develop this slide with him over the course of the last couple of years and what it means. So we're trying to push a message here. And I know some of the audience here may not be connected with that, but this actually is a broad scale push of information across industries. So everything from exploration to Siemens, big production plants making the stuff that they do as well. So where do we get where do we get involved? So the complacency cycle is what we call the broad risk, and we've normally look at it from where it starts, which is a catastrophic event. It can be a catastrophic event involving serious injury or fatalities, but it can also mean a near miss, a significant near miss, or it could involve a RID or reportable incident. What normally happens then in industry there's an inquiry. It could be an HSE inquiry. It could be an internal inquiry. And then what falls out of that is a plan to add resources into it and allocate it in order to address those hazards and hopefully invest some money in prevention. The key indicators for that then identify the controls are imposed and monitoring, etc. And then what happens is that the risks then diminish. They diminish to a certain point, and then the resource is no longer justified, apparently. The investment stops, and what we find in some larger organisations where people don't stay in there, corporate memory and corporate knowledge is lost. You get, I'm going to use a term now which is now used more in modern sort of affair, the Doge types start to come in, and we start looking at where we're going to be able to cut funding and where we're going to be able to cut practices. Everything looks absolutely fine. We don't need to invest any more money in machinery compliance. We've got what we need, etc. So future planning, future proofing, and what we find is that newer, more modern machinery no longer features in the CapEx plan quite often. Workplace cultures change, personnel change, and unfortunately, back around the circle we go. So the resources diminish, controls are removed, risks start to increase. People then miss the key indicators. They're not looking anymore on the controls necessarily. And then we get to a stage where we're back to a catastrophic event or a significant near miss again. And so the cycle repeats. So I'm going to refer back to this slide towards the end. But what I'd like to do now is just go through a little bit of stuff around compliance and conformity. Pretty dry subject, pretty uninteresting and uninspiring to a lot of people, but unfortunately, compliance and conformity should be one of the hooks on which industry does hang its coat. The regulations and legislation do hardly change. You know, we're all subject to the Health and Safety at Work Act, etc., etc. Hasn't changed for a very, very long time. But on the horizon, coming up now as we start to find our feet a little bit after Brexit, we're starting to work out what that means with regards to regulation, legislation for the UK, and how that then ties up with our European counterparts and also any other partners that we're going to be looking at working with in the future, for example, America, Canada, Southeast Asia, etc. So it's all about keeping your eyes on the updates, and this is the big message to industry at the moment, is making sure that whilst you think you're legally compliant now, first question is, are you? Second question is, what can we do to future-proof that, and what do we need to do to keep our eye open for moving with the times? So I'll just touch on three main groups that I think this tends to affect. So we've got the manufacturer, the supplier, and the end user. Now, underneath of those, I've just drawn out the key headline legislation, directives, etc., that I think affect those three groups individually. But there is a lot of crossover, which I'll touch upon in a second. So what I'm thinking here is if you think of a piece of machinery, or you think of an installation, so maybe a number of machines or a system of machines, the question ultimately lands at whose responsibility does it lie with to ensure that the machine or the machinery or the installation complies, and what with? So can anybody, we'll work from left to right, so hands up for manufacturer. Okay, hands up for supplier. Hands up for end user. Okay, majority for end user. The answer is actually yes, everybody, except the person that usually gets smacked the hardest is the end user, because it's them that are going to end up usually in the dock or being prosecuted by HSE. And one of the reasons for that is the manufacturer or the supplier. Supplier is usually UK. If you're buying a machine from the EU, HSE don't have a jurisdiction over in the EU or any other countries, so they can't prosecute the manufacturer. They could potentially prosecute the supplier, but generally speaking, it's the end user that gets prosecuted. So the end user's really got to be quite diligent on exactly what it is that they're looking for. So how do I know as an end user, am I compliant? Can anybody give me one of the key indicators when you buy a piece of machinery that gives you that sense of safety and compliance? CE marking or UKCA marking. Right, so Regulation 10 of PURE, so provision of use work equipment regulations is something that is really the focus on here. If you've got lifting equipment, it's LOLA. If it's pressure equipment, PSSR. And anything that produces noxious stuff or whatever it is that can harm people, you've obviously got the occupational hygiene and health regulations, etc. So all of those fall underneath the Health and Safety at Work Act. And there's a plethora of other regulations involving PPE, etc., which I've not touched on here. I'm just using the highlighted ones. Under PURE, Regulation 10, that's about community conformity. So theoretically, if I've got the documentation to say that that machine has been designed and built in accordance with the Machinery Directive, or if it's for use in the UK, it's the Supply of Machinery Safety Regulations, then I should have the confidence that that machine is safe. However, and it's a big however, at the moment, sorry, I'm getting ahead of myself there. At the moment, we go in and we do PURE assessments into an organisation. We'll ask to see the Declaration of Conformity Certificate for that, or the Declaration of Incorporation. Quite often it lists out the directives to which it's been built, the standards to which it's been built to, hopefully harmonised standards. And quite often when we look at that with a brand new piece of machinery, what we're finding is that the standards that have been quoted within the Declaration of Conformity Certificate are no longer applicable. They've either been superseded or it's now been turned from a Type A, Type B, or it's now been amalgamated into a Type C standard. Type C standard is machinery-specific standard. So we've got people outside of the UK, and sometimes even within the UK, I won't say who they are actually building machines which are built to the wrong standards. It's not always the case. So a bit of due diligence. The problem is that a lot of people that buy stuff, I'm a consumer as well, you see a CE mark or you see a UK CE mark and you expect it to have fulfilled the requirements, the essential health and safety requirements under the relevant directives. So unfortunately, there's only very, very few prosecutions. I think there was one between 2012 and 2022 where somebody was actually prosecuted under Regulation 10 where it wasn't actually CE marked properly. The majority of the prosecutions occur around Regulation 11, which is to do with access to dangerous parts of machinery, so lack of guarding, etc. If I get invited back again, I'll be in a position to give you specific examples of this, but at the moment I'm looking at holistically on this and trying to send a message about it in general. Now, where we've got control over this at the moment is, as an end user, you haven't really got a lot of control if you're buying something off the shelf, but where you have got a bit of control is where you have got an idea for a machine, a requirement, statement of requirement, you're dealing directly with the manufacturer and you can specify exactly what it is that you want to happen. And what that machine needs to do from a legislative or from a safety point of view. So things like, I need it to be guarded in a specific way because where I'm going to put it in my factory or where I'm going to put it in the location, I'm going to require it to be in a pedestrian, a zone that's basically frequented by pedestrians. So what I'm looking to do is have pedestrian segregation. How does that fit with the type of guarding that I'm going to require? And we go back to the manufacturer and we involve them in that design process at the very beginning. Also, how am I going to inspect it and maintain it? So a conversation again with the manufacturer to get that involved in the design at that stage. Ideally, what we're looking at doing is we're looking at trying to be as compliant as we possibly can. And by doing that, we're going to be compliant with PURE at the earliest of stages, which is going to save you a lot of headaches. So by doing one thing, you're actually you're kind of ticking a box in another part of the regulations without even really trying. So how can we do this from a more pragmatic approach? If I take this slide here, the Plan, Do, Check, Act. Oh, it's shifted around since I sent it over, but anyway, check. The profitability is dominated by effective procurement of the right machinery and safe and efficient and effective use of it. So there's an appreciation of this, of what I call the PDCA process. It can iron out many of the issues whilst the machinery and the process is actually still on a design drawing board. You can actually do that from the beginning without having to then reverse engineer stuff and add things on at a later date, which is what, unfortunately, we find ourselves doing quite a lot. So the first, obviously, bit is the planning bit. What do we actually need? What is the workspace looking like? What are controls am I going to need in place for that? Am I going to need access? Is it going to be in a position where I'm going to need lockout, tagout procedures? Am I going to need a specific, because of maybe it's ATEX zone, for example? Am I going to need a particular SIL rating, so safety rating on that? Parts, maintenance, longevity. I'm going to buy a machine, or I'm going to ask somebody to design me a machine or a system. The longevity of that is, am I going to be able to get parts for it? Where am I going to get my parts from? Et cetera, et cetera. So from that point of view, you're looking at sustainability. How am I going to protect my workers? Do I need specialist PPE for that? Am I going to, what's the engineering solution to that? Can I engineer that out? So all of these sorts of things need to be then put in the statement of requirement for the manufacturer. On the back of that then, whilst it's still on the design board, what was my training process look like? This is going to be a piece of bespoke machinery. What training am I going to need to put in place? How am I going to deliver that? How am I going to record that? What risk assessments do I need to be putting in place? Do I need to put in a safe system of work? Can we generate one now? Once you start getting the feedback loop on that, then what you'll find is that actually that safe system of work's not going to work, but what I need is a safety device that's going to prevent me from doing something awful to myself or my people. So we go back to the manufacturer and we try and incorporate that in. So do that, maintenance inspection obviously as well, and you can look at your records. The check bit is the system monitoring, the performance, how we're doing that, what data are we collecting, what are we going to use that for. So this then comes back into the asset management side of things. And then we go into health monitoring as well, because if we're producing stuff that's not very nice to people, cutting fluids, atomized cutting fluids aren't very nice for that sort of thing, and also for skin, but also dust, any sensitizers, etc. All that sort of business needs to be considered in that. So we should incorporate that into our paperwork system, if you like, the risk matrix. And then when it comes down to the act, we're looking at how we're going to collect and analyze that data produced by the maintenance records, for example. How can we use that for targeted maintenance? We're looking at trying to avoid downtime. We're looking at updated standards as well. I'm designing a machine right now, but in the background, I know that standards, that harmonized standard, the BSEN ISO standard, it's up for review. So by the time I've got this off the design drawing board, and by the time I've actually cut metal and I've actually made the machine and it's been delivered to site, is that standard now going to be the last standard and a more modified standard going to come into place? So I need to be looking at that. And then evolution of the design as well. So technology changes. I'm going to invest a lot of money on this piece of machinery. What am I going to be able to do in the future? How's AI going to affect it? Can I capitalize on AI for that sort of, to enhance it? What standards, what regulations, what legislation is going to be in place that might affect that? You know, am I going to be able to incorporate AI if it means that the machine now is potentially going to run away with itself if I incorporate that into it? So what's heading in our direction? Once you've done that and you've put all of those ideas in place, and then you've actually got a firm plan for that, and then the machine arrives, we just go back around the circle. We just carry on doing it. Now, I'm probably teaching people in here to suck eggs, but from our experience as an organisation, this is how I'll be brutally honest, this is how we make our money. We get invited into organisations all the time, some very good organisations who just sometimes need a little bit of a hand. So what I always try and say is, look, if we can get this right, and we put a cultural we teach people this in a way where it becomes part of the organisation's culture. You write it into your own working practices or whatever it is, then we continue this cycle of getting it right. So ideally what you want to be doing is nudging the tiller as opposed to changing major making major changes in the direction that you're heading. So doing this is about nudging the tiller, just keeping you on track, looking out in the future, looking ahead. So it's all about, instead of head down, arse up, it's about looking up, looking out, and making sure you've got the support within your network and within your business to ensure that that's maintained in a healthy condition. So basically, just going back to the original slide here, what we're looking at doing is disrupting this complacency cycle. So try and forget about, we'll not forget about the left-hand side, we just don't want it. So what we're looking at doing is disrupting this complacency cycle once you've got a decent system in place and you've got the machinery and the processes that are safe. And as I was referred to in the previous slide, you've got a decent plan in place. You're replacing post-catastrophic event activities with periodic audit and assessments, and you're keeping on top of the relevant key indicators that are ensuring that controls are imposed and developed. All of this will help tremendously with the P12 concept being satisfied. It will keep you out of court, and it will keep you, more importantly, it will keep folks safe and the business financially healthy, all being well. So I'll just leave you with P12. Thank you.
Any questions?
Thank you, Richard.
Sorry?
On your risk assessment, you mentioned earlier about mine winders.
Yes.
Now, presently, a lot of the winders have been converted digital mine winder controllers from the old Lily and the other forms. How do you get across the barrier whereby the PLC programming is held by the manufacturer, example ABB or Siemens or whoever is developing the mine winding system?
So, right, I'm going to be careful how I answer this because currently, I'm not involved directly with Tautus. It's a couple of colleagues of mine that are actually doing the mine winder testing, but I know how they do it and what they're doing with it. Independent testing is something that the HMI, so the Mines Inspectorate, has been absolute about. And more modern technology is about marking its own homework, is what I understand. So some of the more modern stuff that's computer controlled as opposed to a driver operating brakes.
Correct.
What does that look like? What does that programming architecture look like? And is it infallible? The answer to that, without going into too much detail, is no, it's not. And actually, as work is being developed on this, and we are going out independently and testing systems, we are finding some interesting work around that. So what I would say is I can't say anything at the moment, really, any more than that, but watch out for news coming potentially in the very near future on that one. But it is something that is a concern.
Why I asked that question, the company I worked for, we commissioned a large winder in the Tanami Desert in Australia. It was a ABB, over Lily Bodgy, ABB, and basically they had ABB mine winder control system. And during the commission progress, we could not get access to the program parameters. And whereby in the past, we set up the Lilies or the mine winder controllers, we do a set artificial level, do the whole mine winder commissioning. But why I ask the question is, it is very, very difficult to get info out of the people, ABB, but I assume it's the same with people like Siemens or other people.
There's Siemens and CMAG and...
well, CMAG is Siemens and...
there's a load of other organisations out there as well. Yeah.
So that was the question asked you. But also on risk management, do you do the 5 levels of risk management in the matrix when you do analysis?
On the, what, for mine winders?
On
anything?
On general equipment.
We use it depends on how you define that. So what likelihood and severity?
Well, likelihood of happening will happen
Yes.
Unless, yeah, so you do
Yeah.
risk
And we also
analysis.
work within the framework of particular organisations as well. So a very famous chocolate manufacturer not too far away from here uses us, and they've got their own system, which is very complex, very interesting, and it takes some of the subjectivity out of it, actually, which is not necessarily a bad thing. 5x5 matrices that everybody seems to use is quite... There's a lot of controversy about whether or not it actually does anything. How useful is it? I'll go into an organisation and have a look at something, and I'll give them maybe a different risk scoring to it, say with even one of my colleagues, which is where collaboration comes in. So how accurate? Yeah, it's an interesting sort of thing, but ultimately we'll be leading you towards a similar direction for an answer as to whether or not it's high risk, medium risk, or medium high risk, depending on who you are.
It's usually 5 levels.
Yeah. But I mean, you can go to the nth degree on that one. But then it's the testing of that that's really important. Once you've done the risk assessment, is then to test it robustly before you actually put it into production or whatever it is. And where we like to do that is where we do factory acceptance testing. So before it even leaves the factory or it's being manufactured, we'd like to go there. And it's not about going on a jolly, but we want to make sure that before it leaves the manufacturers, anything that needs to be fine-tuned does that there, as opposed to flying these guys in to unscrew it later.
That's fine, thank you very much.
We'll call that one there.
Yeah,
So
thank you very much. Cheers.
Good to go. Thank you. Thank you very much for the opportunity to speak to you today here in northeast England about a mineral exploration project in northeast Scotland. So one northeast to the other. My name's Fraser. I'm CEO of Aberdeen Minerals. I'm a geologist by background, so in this presentation we will be talking a little bit about rocks, but this is only a little 20-minute teaser. If you want to hear me talk for probably about an hour about rocks, then please do come to my talk right here at this venue in June next year. But for the meantime, quick introduction. Aberdeen Minerals, we are a privately held mineral exploration company focused entirely on exploration in northeast Scotland. We are exploring for deposits of nickel, copper and cobalt, and we do that in partnership with local landowners. Mineral rights in the UK certainly for base metals generally reside with the landowners themselves. So to get onto land and carry out exploration, you need to reach private agreements with those mineral owners. That is the foundation of our business. We have about 56 or 57 private landowner agreements at the moment, covering about 80 square kilometres in total. We are based in Ellon, the town of Ellon in Aberdeenshire. Very small business. We've only got 6 employees, including myself. We've got about 80 shareholders, the largest of whom is Central Asia Metals, which is a London-listed mining company producing copper from Kazakhstan, lead and zinc from North Macedonia. In May last year, they invested £3 million in us, which enabled the exploration work that we're currently undertaking. And they've got an option to invest a further £2 million once we complete that initial £3 million spend, which we expect to be later this year. We're also fortunate enough to have the support of the UK government. We received a £300,000 grant through the Automotive Transformation Fund in October 2023, which we put towards a mineral processing study. Again, more about that and the outcomes of that in my talk in June. So nickel, copper and cobalt, the focus on these three metals are critical to general industry, but also increasingly raw materials for the energy transition. Nickel and cobalt have traditional industrial demand in steel and alloys. That demand very much dominates the market right now and will continue to do so into the future. But we will see increasing demand for nickel and cobalt as battery cathode raw materials, especially in the automotive markets. The challenge with these metals is that the mining and refining of them is highly concentrated. We had a discussion at lunchtime there, just highlighting the fact that Indonesia has basically become the dominant producer of nickel. Around about 64% of that market last year, and that looks likely to increase even further as the cheap materials that they're selling to the market basically undermine the Western sulfide producers. But nevertheless, both nickel and cobalt do feature in the UK critical minerals list. So they're considered to be strategically very important. And copper, of course, is ubiquitous in everything electric. And the key thing about each of those metals is that there is no primary production here in the UK. So why focus on the potential of North East Scotland? Well, the map on the right there is a map published by the British Geological Survey that highlights the geological prospectivity, the geological potential for various critical raw materials. The darker the green colour, that indicates that multiple of these materials are considered to be prospective in each of those regions. You can see there that North East Scotland features quite strongly. And that's because the geology is very favourable for nickel copper sulfide deposits in particular. There are several documented discoveries. We're working on one of them. The favourable geology has historically attracted large mining companies. Rio Tinto consolidated goldfields in the 1960s, ABMEC in the 1970s. Falconbridge also took a look at the area. And Inco, a large nickel producer that was taken over by Vale, was active in the area in the mid-2000s. Despite that history of exploration, the region is very much considered to be very much underexplored using modern exploration models and technologies. It's an area that's very rich in infrastructure. Good access by roads, excellent access to energy, in particular increasingly renewable energy. The area where we're working is about 20 miles away from two major ports, one at Aberdeen, one at Peterhead, and we also see great potential for a future workforce. So the project area, more specifically, the map there on the right-hand side, that's a simplified geology map that highlights those green areas are the mafic, ultramafic, intrusive rocks that have the potential for these nickel copper sulfide deposits. Deposits of this type were discovered in the late 1960s by Rio Tinto within those prospective Gibralwick rocks, which formed 470 million years ago during a major mountain building event called the Caledonian orogeny. The area we're focused on is called Arthrath. It is currently the largest nickel deposit in the UK, and there's a very interesting little discovery story that involves neeps or turnips. And again, if you want to find out more about that and the role of root vegetables in mineral exploration in North East Scotland, we can talk about that a bit further in June. So a lot of drilling in the 1970s, a little bit of work in the mid-2000s, but basically no meaningful modern drilling until very recently by ourselves and our colleagues in another private company called Peak Nickel, who are operating over in the western belt on that map there in the area shown as Little Mill. And what we're both doing is applying the latest geological models, the latest technology, investing in drilling for the first time in decades to establish a new exploration paradigm. And central to all of that is the formation model, what we call the magmatic sulfide conduit model, which was only developed since the 1990s, so after a lot of that historical exploration took place, and this is why we have a new paradigm. We actually have a different basis in which to fundamentally to explore for these deposit types. This model type just wasn't known about, it wasn't considered until the 1990s. And the diagram on the left there basically shows a magmatic system. So magma is the molten rock that is intruded into the Earth's crust from the mantle. And that's obviously a very hot, high energy environment that brings the metal budget together with the magma. As the magma interfaces with the surrounding country rock, it assimilates sulfur. The sulfur then forms a separate magma made up of iron sulfide, and it's that iron sulfide during that magmatic phase that actually preferentially attracts in any nickel or copper that's floating around in that magma. So the metals of interest are sequestered into sulfide, and then when the magma cools down and starts to solidify, the sulfide minerals are very dense, and so they preferentially gravitate towards the base of these intrusions and form metal-rich accumulations of massive sulfide in trap sites along the base of the intrusions. Now, the reason why I'm dwelling on that is fundamental to our approach, the detail in which and the depth to which we actually carry out our exploration. So the key to exploration is understanding whether first of all, we're in one of these conduit environments, and then understanding whereabouts we are in the conduit and identifying, vectoring into the best parts to target with our exploration. Because metal-rich sulfide deposits tend to actually be quite small. So the map there is a zoomed-in map showing the Arthrath intrusion, which forms a 7-kilometre long sort of east-west trending appendage to another major intrusion. And that map is at the same scale as the little diagrams down the bottom of this slide. The red areas in those diagrams show the footprint of major sulfide deposits elsewhere in the world. And as you can see there, you can actually fit many of those deposits multiple times over within the Arthrath intrusion. So we basically have quite a large playing field at Arthrath, and the little black dots on that map are the historical drill holes. So yes, there has been historical drilling, but it's by no means been comprehensive along the totality of the target intrusion. And this is another view of the intrusion. The diagram on the left there is a three-dimensional model that we've used our geophysical data to actually model the form of this intrusion at depth for the very first time. And remember from the previous slide, we are targeting the base of this intrusion. That's where we believe the sulfides are actually accumulating and forming these metal-rich deposits. And the little lines across the top of that model show the extent of historical drilling and some of our early drilling. You can see that we barely scratched the surface. If we're targeting that zone highlighted in red at the base of the intrusions, then we haven't even got close to testing the best environments. And again, just to show an example of just to illustrate the scale of the prospect that we have, that diagram on the right is a cross-section through the Nova Bollinger nickel sulfide mine in Western Australia at the same scale. And the orange and red outlined areas there are the semi-massive and massive sulfides. Those are the economic parts of that deposit. And again, you can see why we're pretty excited about the scale of the opportunity at Arthrath. There's plenty of scale, plenty of scope to host deposits of that scale. But carrying out that exploration requires persistence. It requires deep-seeking geophysics. It requires investment in deeper drilling. And those are the steps that we've been following over the past 2 or 3 years with our exploration. We've invested heavily in geophysics, bringing the latest technology to this area that hasn't been explored in over 50 years systematically. The key property of the nickel sulfides is that they are electrically conductive, so you can use electromagnetic geophysical techniques to directly detect these deposits in the subsurface. And the deeper seeking the geophysics, then the better opportunity you have to actually find these deposits which remain undiscovered. So latest technology lets us see through the surface cover, explore for these deeper deposits in more detail than has ever been possible before. We then use other ground-based and borehole geophysical systems. Again, some of this technology for the first time in this area to expand the search space of our exploration. But the key thing really is drilling. You can only do so much with geophysics. It tells you about the general properties of a target area, but until you actually get a drill hole into the ground, you're really just guessing what the geology is doing. So we've drilled 21 holes since 2023, totaling 7,000 meters of drilling. The longest hole that we've drilled so far was in this summer's program. We drilled a hole that was 515 meters, so half a kilometer long, which did reach the base of the intrusion. But that's the type of drilling that you have to do to really fully explore. So we've been doing a stage program over the past 3 years. In 2023, that was our first drilling campaign. We delivered the proof of concept, and I've got a slide in that in a minute. Last year, we extended our search to put in even more deeper holes and identify targets to focus on. And in 2025, we've continued that work, and in actual fact, only demobilised the drill rig from the latest round on Tuesday this week. So we're just coming off the back of another exciting summer drilling programme. This is what this slide shows what the exploration area looks like. You can see from the top part of the image that we're in industrial agricultural farmland. Very kind of low topography, low relief around this area, so very easy to access. Depending on the time of the year, good field access to get on with the drilling, and you can just about see one of our drill rigs set up in that barley field there. It's a very small footprint exploration operation, and the picture on the bottom is a bit of a close-up of that drill rig. So low impact, low footprint exploration, but in terms of our technical success, really exciting and high. Basically, the drilling that we're doing is transforming our understanding of the potential of North East Scotland. So it's an exciting time. This slide here shows basically the picture as we had it upon completion of our 2023 drilling programme. You can see there the line across the cross-section there on the right-hand side shows basically the depth of historical drilling. We put one drill hole 100 metres below that historical drilling and hit some of the best sulfide textures that we've seen on the project. So the diagram on the left is a picture of some of that drill core. The kind of yellow brownish minerals are the sulfides, so you can see there where they're becoming more concentrated against the black host rock. So then 2024 was about taking that concept a bit further, that the deeper we go in the system, the more prospective it becomes. Again, remember our model, we're looking for parts of the intrusion where we hit the floor, or we hit little kind of nooks and crannies of that intrusion where these sulfides, these dense sulfides become concentrated in gravity traps. And that's exactly what we found in our drilling last year. In fact, we didn't even have to go that deep. At about 200 metres vertical depth, as shown in the cross-section there in that middle diagram, we hit some of the best sulfides that we've seen. We hit 33 metres at 0.8% nickel equivalent, with some of those textures shown on the diagrams on the right-hand side. Remember, the more sulfide we have, then the richer the metal content. And this year's drilling has just taken that all a step further. What we found is that in certain parts of the deposit, we still didn't actually know where the floor zone of the intrusion is. So because actually understanding that part of the geology is a key part to our model, it was very important just to get a more deeply penetrating hole to understand where the base is. And the middle diagram there, top center, shows hole 17 actually intersected the intrusion floor. The shape that's shown there, that three-dimensional shape, is basically that three-dimensional model that we have based on our geophysics. We actually intersected the floor within about 20 meters of where our model said it would be. So really exciting stuff that our modeling works. The exploration system there, the prospective geological system, is in operation. We just have to put more drilling in to test it. And some of the drilling results that we had from this year program have given us some of the best geological textures that we've seen. The top right-hand diagram shows sulfide matrix breccias that have formed, where basically there's been so much sulfide in the system that it's actually brecciated the host rock. And those are the types of geological clues that we want to follow to continue our exploration in the hunt for metal-rich massive sulfide deposits within this prospective system. So we are really excited about our exploration. We feel as if we're kind of just getting started. We've got another phase of drilling to look forward to probably into next year, subject to further financial backing. And key thing about operating in northeast Scotland, if we consider where our nickel currently comes from the jungles of Indonesia and elsewhere, we think we've got a real advantage here by developing this type of project in an area like northeast Scotland, which is a pre-existing industrialised landscape. We can leverage existing infrastructure. We can win value for communities from land which is already nature degraded through intensive agriculture. And of course, it can all be controlled by a very robust planning system to ensure that when we do secure raw materials for our energy transition, it's done in a suitably responsible manner. Thank you very much.
Any questions?
How are you going to get it out? It's very good news. You've really good deposits. How are you going to get it out of the ground?
So the model that we're following and the nature of the target type, because we're looking for these deeper, higher value, but potentially quite small deposits, that target type is well suited for underground mining techniques. So you would access it through an underground, an adit or a ramp, and all your mining would be done underground. And you would bring that material to surface where it would still need to be processed. So you would still need some processing infrastructure, but if all you have is your processing infrastructure on the surface, that results in a much more limited footprint compared to, for example, an open, the type of open strip mining that's currently being used to source our nickel.
It's about support from the community at the end of the day.
Very much so. Yeah. It's about making the most of the natural resources available to us, but developing them in a way that is responsible and acceptable to those communities. Absolutely.
That was very interesting. That it's obviously you've only done preliminary drilling as such, and you haven't obviously got the extent of the maximum strike of the ore body yet, so it's very, very hard at this stage to put a resource on there. How long do you think it'll be before you'll be able to add in resource of what you may or may not have?
Yeah, that's obviously, the sooner we can get to that point, the better. There is an existing deposit, and we've got a good handle on the grade and tonnage of that existing deposit. But it's not our ultimate target. We're looking for the deeper deposit, which we believe is there, which is higher grade.
Yeah.
But as soon as our exploration outlines whether that deposit exists and then gives us the basic scope of it, the intent then would be to do the detailed drilling required to bring it up to a resource estimate as soon as possible.
So with a few deposits, you're looking at another one further away, you could end up, this is only hypothetical, that you could end up at a central concentrator and a series of small, discrete underground mines with selective mining.
Yeah, that would certainly be of interest. I mean, what we recognise from the geology is that these are not huge deposits. That's just their nature, and also you're looking for very specific. Although we think that the broader northeast Scotland geology is prospective, you are probably looking at a number of prospective sites, and obviously to develop those in the most sensitive way possible, you're looking to use to leverage the infrastructure that we have. So. Yes, ideally a centralised plant of some sort with multiple satellite deposits would be ideal.
Your best hit yet's been, what is it, just under 1% nickel?
Yeah, so there are higher, the intersect reported on the slide there was 33 metres at 0.8% nickel equivalent.
0.8% nickel.
But there are intervals within that were much higher grade. We're seeing individual samples of 2% nickel and above.
That's okay, that's very interesting. You talk about Nova. As I said, I was involved in the Nova job in Australia. Okay, thank you very much.
Yeah, so Nova was only 14 million tonnes. You know, it's not a huge deposit.
I think it's closed along with BHP's because of the Indonesian Chinese. Thank you.
Okay, thank you.
Change the topic, Fraser. Ask you something about property. 56, 57 landowner agreements.
Yes.
That's quite a tall order to get in place. How long did that take you?
Well, fortunately for me, they were already in place when I joined the company, so it didn't take me any time
not your
at all.
problem.
It took the business. So the business was established. Aberdeen Minerals was formed in 2018. We only got drilling in 2023. So a lot of those early years were spent putting those agreements together, building up the relationships with landowners to put that package together, as well as compiling all of the historical data that we had available to us as well.
And did you manage to get the landowners to sign up to a common template, or did they all want their own particular types of agreements?
No, so we use a consistent template across all of our agreements.
Excellent. Thank you.
I'll ask you why you got peridotite. Is it a peridotite cumulus above the gabbro?
Yeah, well, interesting point. So the peridotite, we believe, it's unmineralised, and it seems to have formed an earlier intrusion.
And then it's something's
and then the gabbroic intrusion has actually reintruded and brought the sulphide mineralisation with it. Yeah.
Brilliant. Right, well, thank you very much.
Thank you.
And our next speaker is Angus McGregor from BAM Riches.
Hello everyone. Grab the opportunity to stand up a minute and just shake your legs if you want to. 18 months ago I stood here and sort of did a little call to action just to make everybody aware about what we were on the cusp of. We're still on the cusp, and I come fresh from Paris, where it was the International Hydropower Association. So the reports from Paris are we are on the cusp of an international renaissance in large-scale, long-duration storage of energy to make up for the intermittency of solar and wind, which is the solution to our energy transition. The story is that pumped storage still brings us flexibility. It creates critical grid stability, and as the earlier presentation by Siemens illustrated, we're using these compensators just now for that inertia solution, but we need an awful lot of them to do that, and pumped storage also provides that solution. Importantly, in the transmission solution is pumped storage also provides a sink to consume power when we've got too much of it in the grid, which was a concern for those that lived in the Iberian Peninsula not too long ago. Is everyone aware of the blackouts across Portugal and Spain? So importantly, in Paris, we did discuss that we do need both batteries and pumped storage hydro, and so it's not a competition between short-term and long-duration. These are complementary solutions. So why are we talking about that in the mining context? Well, I'll go on to explore that some more later on. Also from Paris, an international challenge, apart from in India and China, and we did speak about that during lunch, is that there are environmental and permitting challenges across the world from starting this renaissance. Global leadership matters. China's government and India's government have shown what is possible by clear political will, streamlined permitting, and market alignment. China and India are ready to solve the rest of the world's problems, so the world, UK and Europe, saying, we don't know how to get this done. India and China were sending us the message that they have the solutions and are ready to come here to solve our problems. Decide what you wish about what that means. Also in the European context, because of the Brexit situation, UK's aspirations doesn't really feature in Europe's plans. They're vaguely familiar about what we're doing, and there's some interesting research you can probably, I'll signpost you to, is Norway's plans with the power that they currently supply the UK, which might change people's ideas. So just to remind you, our existing fleet of pumped storage hydro, all underground construction, consists of 4 power stations within the UK and 1 in Ireland. We have 2 in Scotland and 2 in North Wales. Our hard rock areas, Turlough Hill in just south of Dublin. How does it work? You were all here last year, weren't you? Do you remember how it works? Keith does. You have an upper reservoir full of water. You let that water out through your hydro plant into a lower reservoir, and then when you've got excess power in the grid, you pump the water back up the hill into your reservoir, store that potential energy for the future. So making up for that intermittency in solar and wind. We have both closed loop and open loop systems. So in a closed loop, you just exchange the same water back and forward. So there are plans afoot for instance, making use of seawater in that instance. Obviously, you don't want that leaking out into the local environment. Or open loop, in which case the water is passing through the lower reservoir. So when I sat here 18 months ago, or stood here, I presented this map, which illustrated potentially 30 prospective sites across the UK, with a predominance really for the hard rock areas where the change in topography, high rainfall or higher rainfall potential, the ability to construct underground spaces in reasonably competent material to cope with the high pressures involved, because we're typically talking about 500 metres of head in these hydraulic systems. In the call to action, some things have happened over the last 18 months, and some things have not happened. However, what is clear is there's now 9 more advanced, and you can see that there's a predominance for projects across Scotland, which is good news for me, I hope. But the reality with these predominance of projects in Scotland, it's not going to call on Scottish resource, or not only Scottish resource to deliver. It's going to call upon national and international resource to deliver these. Each one of these projects is of the order of 1,500 people on each project, and with governmental desire for clean power by 2030 and our net zero commitment by 2050, that means a saturation of resources over the next 25 years in reality, although there's desires to move much, much faster, but mobilising that potential is quite difficult, considering all the other planning aspirations that there might be. So bear that in mind. So what kind of activities are going to happen? Well, very similar to everything else that we've talked about today. So ongoing on the most advanced projects are exploratory drilling to confirm the ground conditions, environmental surveys for ecology, working out how the hydraulic systems are going to interface with each other. And then unfortunately, in terms of timeline, and also that restriction just now, that generally speaking, the deep drilling to investigate the ground can't go deeper than 200 metres. Is there a reason for that, Fraser? Yeah. You just need a license, yes. So it needs strategic thinking, a bit of forward planning, and you need to submit the paperwork. So there's only one project that's managed to go further than 200 metres so far, and that's Corriglass, and they completed one hole to 650 metres. So that's 2 holes. Oh, what's that? You've done it 3 times. Of course you have. And this is why there needs to be the crossover in sectors, because the energy sector, as they would call themselves, is trying to overcome problems that other sectors have already solved. But it's all about having a strategic agenda that we work towards, a bit of forward planning. Okay. In the creation of these facilities, large, very large, humongous laydown areas, flat spaces for process facilities are going to be created for substations and above ground constructions. So we're making holes in the ground in areas where there isn't very much flat space just now, because as you can tell from the previous map, it's all mountainous areas. Most of the solutions are going to involve underground caverns and tunnels, and therefore we're creating portals and spaces in order to enter underground spaces. And typically the schemes involve, each one of them, around 20 kilometres of underground tunnelling in various forms. And each of the transformer and generating halls are underground spaces, as we'll illustrate in the right-hand photo here. That one there. They're cathedrals, between 65 and 80 metres high, between 55 and 63 metres across, 120, 140 metres long, all deep underground, generally positioned with their invert level below the level of the lower reservoir. You can imagine that. So imagine walking into York Minster or Beverley Cathedral or Westminster Cathedral, etc. A space that big, 600 metres underground, maybe 2 kilometres into the hillside horizontally. There's also some dams to build, you know, just minor surface works, but probably the biggest of which, the material for these derived from the excavation of the underground spaces, material reused, repurposed for the construction of dams in order to impound these upper reservoirs. An example would be, for instance, Corriglass, where their upper reservoir is 92 metres high, it's 760 metres long. It's of the order of 160 metres wide at its toe. Millions of cubic metres of material constructed over the period of 4 to 5 years creating a dam. It's not one of those things where you click your fingers. The stuff is mining engineers, mechanical engineers, that we probably can foresee the crossover, large underground spaces, tunnels, conduit, adits, connecting schemes, all with ventilation, lighting, electricity in order to make it safe for our people to work in. Complication as well, when we come to putting water in those tunnels, the rock and lining can't cope with the pressures involved. So getting large steel tubes in underground, and not just underground, getting them from wherever we can fabricate them across the Scottish Highlands to a place where we then drive them underground and then weld them together, calling on resources from throughout the world. The reality being, for steel tubes, potentially manufactured or started to be fabricated, potentially in this part of the world or Belgium, and then shipped in parts to the northwest of Scotland. Anybody excited yet? So here's one of the schemes that's well advanced. They're in their second phase of ground investigation. This is Loch Kemp on the shores of Loch Ness. Loch Ness, where the monster lies, is their lower reservoir, so a huge potential body of water. Idea being that it can produce electricity when there's demand, and then when there's not demand, pump the water back uphill. Or indeed just spin the turbines so that they're ready to pump, or so that they're consuming energy within the grid, providing that inertia that we discussed, or Siemens discussed first time this morning. Getting rid of those lumps and bumps created by the wind turbines and the direct current and all these other things, getting everything in phase, a whole part of engineering that I don't quite understand, but I think it's important. Underground spaces, tunnels, some lochside works, and these lochside works, a slightly different arrangement here in that the turbines, 4 turbines, will be located in deep shafts, 60 metres deep on the shores of Loch Ness, and then the upper reservoir being contained in this instance by 8 dams formed with the material that comes from below ground. And that's one of the potential 9. We need access, or whoever builds it will need access, I have to say. And this is the potential of what's left on the shores of Loch Ness when we're finished, when it's finished. So what's been happening? We talked about we need a strategy. We need to know that's what's been doing. There needs to be a mandate. The mandate needs to tie up with planning so we can get the permitting, all these things. So NESO, who's heard of NESO before now? The National Electricity Systems Operator, used to be National Grid, NESO. So they predict in the future try to predict the different scenarios of what energy we need, where we need it, and how we're going to consume it. They put the strategy in place, they tell us what's needed, and then that really advises us about where the investment happens in the infrastructure, the grid, where we need to produce power. So the big driver is net zero 2050. Well, how are we going to get there? Oh, well, as we discussed at lunch, we switch off all our coal-fired power stations, but currently we're buying in renewable power from other parts of Europe because we can't produce it ourselves. So the time ticks over. Importantly, if we do nothing, we're going to run out of power, and we're going to be the same as Portugal and Spain. The lights will go out. So this is what their future scenarios report tells us, and that kick-starts the process. In terms of supporting the argument for underground construction in the form of pumped storage hydro, their document in 2025 says we've got 2.8, so that's our 4 current facilities. That's in the red circle there. By 2030, we need to have improved that to 5.3 gigawatts. By 2040, up to 14, and by 2050, that's 16.6 gigawatts. So that's 9 or 10 of these power stations built underground and in the ground by 2050 to meet our net zero, alongside all of the BESS units that are currently planned or in process. So 16.6 gigawatts in pumped storage hydro, and up to 40 gigawatts in conventional batteries, which are going to draw on all those critical mineral resources that we're going to need from underground from Aberdeenshire, aren't they? So to follow on that, DESNE's put out the consultation, because things started to move quite quickly after the instigation of the legislation. January 2024, they created a scheme to produce the investment, because one of the issues with pumped storage hydro, you can't invest today and get a return tomorrow. You invest today, you get return in 12 or 15 years' time. The investment markets don't like that. So there was a consultation, there was a response provided, and they went out to the market. Ofgem agreed to be the regulator on that, and then, look at the dates here, they issued their consultation on the 18th of December 2024, and the response deadline was the 8th of January 2025. Guess who had a very busy Christmas? So, all the developers went mad to try and create the body of information, because very quickly after that, in March, they opened their technical decision document, and there was an application deadline to put in applications for your project to support this long duration energy storage, for which they received 171 bids. And they will determine in the next 3 weeks what that output is. What we're expecting to happen is they'll then enter into negotiation with each of those developers to choose which ones that they support in what they're calling window 1, so that's projects that can be complete by 2030, and then window 2, which are those projects that can be complete by 2033. All very aspirational and optimistic dates, I would suggest. Onwards and upwards from that, the other probably 6 projects up to your 13.3 gigawatts will follow. So we need between 3 and 5.3 gigawatts of long duration storage to meet our clean energy goals by 2030. So that's 2 projects complete by 2030. The majority of these projects are going to be in Scotland, but there are other opportunities. But as I understand it today, they're all sort of in the background, sort of following on the coattails. Smaller schemes, 100 megawatts, etc., rather than the mega schemes like Corriglass, which is sitting at 1,500 megawatts. A driver for this, though, is that we're currently wasting 4.36 terawatt hours due to curtailment in wind. So we can produce the power, we just can't get it to grid. So there's a big push. Pathway to 2030 is to sort out the grid, to create Eastern Green Link, so that underground HVDC cable to get it into Yorkshire to then distribute through the system. 2030, we need to be able to store that energy so that we can then discharge it when we need it, because currently we're wasting it. And the policy framework can unleash that private investment. Optimistically, they're saying 15,000 jobs. If the nation are building 2 or 3 of these at a time, that's 4,500 people directly employed on each job project, all within 15 kilometres of Fort William, if Fort William can cope with that many more people. And then the burden on all the other supporting services like schools, social, doctors, etc. This is potentially one of the first to go to site. It's more videos of lower reservoirs and upper reservoirs and tunnels. and we've run out of time. Get a quick flick through. This one's particularly interesting because it's the remediation of a former open cast coal site, and this is a closed system. I'll not play those videos. Corrie Glass is well advanced. They, in terms of planning, they drove a trial adit to 1,200 metres. It's been on site. SSE have a preferred contractor ready to start when the mechanism is released. So the call to arms is BAM are preparing to support this initiative, but the reality is it's going to need sector-wide solutions. Are you ready? Because if you're not, it's going to draw down on your resources because there's going to be a demand to get this energy transition. So you need to be aware that it's happening. And all I'm doing today is to make you aware that all sectors will be affected by this. Thank you.
Thank you very much again. Any questions?
Hi Angus, that was fascinating. Some very ambitious timescales there in terms of 2030 and 2033. Can't see that happening personally, but...
Yeah, the 2030 comes from a desire by the incoming new government to declare clean power by 2030. And so that creates the inertia or enthusiasm without necessarily all the facts, but they have to create that, get it going. One of the difficulties we have to be aware of in a sort of technical community is look back to all the projects that have ever been attempted where we think fast and rush to site, and they always miss their end dates.
Yeah.
My call to the sector would be to say, let's slow it down a bit, think a bit more carefully about how we address these issues. Because all these projects that I've presented there, up till very recently, are all siloised. They're all commercial investments by private enterprises focused on making their project the most palatable to the Ofgem. And no one yet has considered how these projects interface with each other. And for anyone who's ever been to Invergarry, Fort William or Fort Augustus, the idea of constructing those projects, even one of them, just now is going to have a huge impact on the
I absolutely agree about the whole concept of having to think cross-sector and getting different professionals together around the table. We've had some involvement at Corrie Glass, for example. You mentioned these massive cathedrals and tunnels. That creates an awful lot of waste stone.
It does.
Corrie Glass, they haven't decided what they're going to do with the stone that's come out of the test hole yet, let alone the bigger project there. Are you thinking ahead at solutions for that sort of thing, virtual quarries or other use of that material?
So the aspirations for Corrie Glass is that all underground material will make its way into the dam if it's suitable. But until it was a great incentive for them to complete the trial adit was to determine, well, what is the nature of that material and what does it look like once it's produced? Does it have engineering properties, etc.? There was huge concern about unsuitable material, because that then creates the challenge, which we have on all projects, is what do you do with your unsuitable material? Because you've got to create a safe home for it. And for that project, I'm not sure that the story is yet complete. The other challenge that all of the projects face is they all need to relocate peat, which is currently living in a carbon sink, and it's got to go somewhere else. And the somewhere else has to be the same square area as where it's currently come from. That also creates. So it's carbon reduction for the greater good, but it will have an impact along the way, and that needs to call on. Interesting to go to a pump storage hydro conference, 800 delegates talking about it being a sector, and I'm going, well, this is cross-sector. You need to draw upon the expertise from mining and extractive industries across the, as well as the mechanical engineers and every other asset, because they are resource sinks for experts. And everyone, because the last of the UK projects were finished 40 years ago, the expertise that evolved in that time is diminished. The apprentices 40 years ago are thinking of retiring. Yeah, never mind the ones who were the technical experts or the managers or etc. who plan things.
Just regarding the cathedral-like spaces, is that where the machinery goes? You pump generators?
So typically, broad brush, either 4 or 6 of the turbine generators in each one of these spaces. So you pass the water through them underground.
Oh, well, my question was, I did some work a couple of years ago on the Luddington power storage facility in Erie, in the US, on Lake Erie, and they were actually retooling, so they were replacing the motors and generators, the huge motors and generators. That was actually all surface work with a crane, so that was quite easy. And I just wondered what provision you'd made to change out the machinery, which will inevitably go wrong.
So
inevitably over time, at some point it'll need to be replaced, mechanical seals, etc. I just wondered how that would physically be removed, be exchanged.
So the sector's storytelling is that you build a pumped storage hydro scheme and you have it for 100 or more years. You build a battery storage system, and after 5 to 7 years, you're stripping it out and replacing the batteries, typically. So even that's the nice investors, the investor story or promotion. So examples are Cruachan is one of our current pumped storage hydro fleets. It's run by Drax. 40 years after it's, more than 40 years, they're doing a refit now. So the complexity involves that conversation of understanding its longevity and going, well, you're not creating these cathedrals just for the period of time until the turbine's exhausted. You're creating these underground spaces so that you can pull the turbine out and replace it and replace all the parts. So that, for Cruachan, that was built in, but it was built in from a perspective of 1953. So Cruachan faces an issue that 2 Series 1 Land Rovers can pass each other, but 2 Toyota Hiluxes can't, because there's that gradual growth. At HGV delivery to Cruachan has to reverse 1.8 kilometres in because it can't turn up in the cavern. There's the capacity to remove the turbine and all the components, but the logistics of getting it into the space becomes the challenge. Mike Wang did a really good presentation at ABMEC on that.
Brilliant, thank you very much. Microphone, Andrew, please.
Ladies and gentlemen, I'd like to thank the organisers for the invite to participate in this event, and it's the first time that I've had the opportunity to come across and give some views on what we do at Central Alliance within the mining space, and it flows over into other industries and other sectors as well. My name is Dave Capstick. 35 years plus, I'm a geologist in the mining sector, but I've done many other things within mining apart from geology. Let me do a little bit of an explanation of where we sit as a company. I work for Central Alliance. Central Alliance are part of RSK. RSK is a very large British independently owned company that comprises of over 250 different companies. So for me to explain it completely would be quite difficult, and I'm not going to attempt that. But the overriding aspect of the RSK as a company is that it's into geotechnical and environmental engineering and consulting over a wide range of industries. Site Auto, the other thing you see there is a division within Central Alliance, and we focus on remote technologies. And the title of the presentation is Harnessing Remote Technologies and Applying AI Data Analytics to Provide Real-Time Surveillance and Data Insights. So this is where two really rapidly evolving technologies in terms of remote monitoring and AI are colliding, if you wish. So let's give some examples of that and talk through it. We have three pillars within the work that we do at Central Alliance. We are about acquiring data in all sorts of different forms, and I'll go into that. Once you've got the data, you've got to look after it, you've got to make sure it's secure, you've got to make sure it's available, you've got to make sure that it can be accessible, and we have various aspects that do that. Did I press that then? I must have pressed it by accident. And finally, we have another different types of technologies that also play a part in this role as well. So here's a little infographic that describes that sort of thing. So when we talk about remote monitoring, we're talking about monitoring from satellites, which we do on a regular basis, and we are well versed in that and considered leaders in that. We look at data hosting within the cloud, and there's a little cloud to show what the cloud technology looks like, because not a lot of people know it. It's a little fluffy thing that floats around. We use fixed wing, and we use UAV drones, and then we also have the ability to do in-ground instrumentation and monitoring. And further from that, we also have a underground and in-tunnel monitoring system, which I'm not going to touch on today, which is, and I've presented before, is muon tomography, which uses the passage of cosmic rays through the Earth to generate 3D density models. But I'm not going to touch on that today. So once we've got the data, the trick, and always is and always will be, is to turn that data information to information and then to knowledge. So it's the old story of getting the right information to the right people at the right time, so hopefully they can make better informed decisions. AI analytics plays a role in that, and I'll explain that on the last slide. It just gives an extra power and a boost to what we can do with data. So these are some of the things that we use. Then we've got a chopper with one of our survey systems fitted on the front. I'm not going to photograph the satellite. We use various satellites. And what we tend to do is look at INSAR data. So SAR is synthetic aperture radar, and that is particularly useful in understanding soil moisture. So we use that within a mining space, but we also use it within a geotechnical space as well. Aerial studies, and you can see the chopper there. UAV studies on the right-hand side. There's one of our drones fixed with what looks like 2 TV aerials, old ones that have fallen off somebody's roof. It's a bit more sophisticated than that. So they are picking up SAR band radios, radar waves, but on different levels. So we've got P-band, C-band, L-band, and B-band. So we've got a chance of doing multi-band SAR, which is a real crucial difference of that. And we are the only providers of that technology in the UK. You can see on the bottom slide, so these are some of the in-ground sensors as well, and gateways, and various types of telemetry to move this data up into the cloud. So some example of work, and I'll just say and introduce some of our colleagues on this, or University of Stirling and Cranfield. In terms of the UAV type work, Cranfield do a lot of advice and a lot of background work in terms of the technology of the sensors themselves. Stirling University worked with us to do some of the algorithms that transform the raw data from the satellites or UAV SAR work into soil moisture information. So satellites are good, and we've used them a lot. We've done a number of projects with them. It tends to be on L-band, which is a particular wavelength. You can get big tiles of data, 20 to 100 kilometres square. It's a big wad of data to look at. The resolution is between 10 and 20 metres, which is okay, and it gives you a good first initial look at it, yeah? However, more recently, and that's over the last, say, a year and a half, 2 years perhaps, we are able to provide multiband SAR studies, and like I say, we are the only people that are doing this in the UK at the moment. And here we're using CL and P bands. And you can see from those slides in the middle there, the different wavelengths enable measurement of top of canopy, the surface itself, and the soil moisture in surface as well with P-band, and getting much more penetration. There we're showing 60 centimetres or something like that. Depending on the ground conditions, you can get closer to a metre, but it depends on the geology. So because you can get different levels of data, it means that, one, we can see soil moisture through vegetation, which is a critical aspect. And secondly, we can start understanding the levels of biomass as well. And we do a lot of this sort of project now with both agriculture and other sort of industries that want to understand what the biomass of that particular area is, particularly in these days of net gain in biodiversity, which is a key element to projects and certainly will be in future. With multiband SAR as well, it also enables us to really get a much higher resolution of information. So instead of 10 or 20 metres in terms of soil moisture, we start looking at 10 and 20 centimetres. So that's a hell of a step forward. We're getting some real detailed information of what the soil moisture looked like within the biomass and within the near surface. So the types of studies we do, soil moisture, agriculture, mine tailings we've done studies on, and flood management. You can see at the bottom left is a satellite study of a river floodplain environment. I think this was in Wales. And again, it's picking up the warmer colours are higher soil moisture, yeah? Biomass, we do crops, forestry, subsurface types, biomass. So we've done a study recently with the University of Aberystwyth, whereby they're growing a biomass crop called Mycanthia. So it grows, they chop the things down and they send it off and process the stuff and it grows and that. But they've worked out as well that the root stock of this Mycanthia is enormous. And it also leads that the companies that are involved in this can use the root stock as a carbon credit because it's a carbon sink. But how the hell do you measure your root stock? It's a pretty difficult thing to measure, yeah? But because we can penetrate the subsurface and we can measure the areas of soil moisture within the rootstock, we can measure the below surface rootstock and therefore the level of carbon credits. It's work we're currently doing, but it's going very well. Shallow voids, so the stuff on the right-hand side is somebody decided to release a lot of beavers in Scotland. They became a nuisance immediately by making burrows. That was very inconsistent of them, inconsiderate. Anyway, so Network Rail wanted to know, where are these burrows? So we flew the drone over, and you can see the white dots there, up there, so that's where we're able to measure by UAV beaver burrows. Since this has been sent to Network Rail, they're very happy about it, and they've sent us on to sort out the bigger and more disruptive cousins, the badgers. So we're doing a flight, we've done a flight at the moment in Scotland for Network Rail, and we're doing the processing. So in terms of instrumentation, so this is putting instruments in the ground, piezometers, tilt meters, pressure sensors, etc., etc. And we do a lot of this sort of work for different sectors, but it enables us to ground truth any airborne studies, which is critically important, as you can see. Now, there aren't too many companies that have this capacity of handling this spread of data in terms of ground conditions. We've got 7,000 sensors in a network rail in the western region, monitoring long rail tracks in terms of embankments and monitoring soil moisture conditions for slippage and movement of rail embankments. And on the bottom right, once you've got the data, we need to move it, telemetry, and those are the sort of four of the protocols that we use to move this data up into the cloud and make it secure. And once it's in the cloud, well, we want to ensure that it's safe and it's available, and you can start drawing down information. We host data for a number of sort of fairly big organisations, Network Rail, BIA Systems, AMCO, Jacobs, the Environment Agency, amongst others. We have our own capabilities of creating portals and dashboards. So this makes it available to the users to start getting a real broad understanding of what's happening on that site. And obviously dashboards are linked to alerts and alarms and put it on smartphones, all that sort of way of communicating effectively of when an intervention is required. Yeah? And again, this is another project we did, I think this was for a water company. One of the things as well is that it's important that when you're capturing this sort of data, it's auditable as well in terms of standards and quality of work and the reporting side as well. So in terms of sort of projects we get involved in, this is another shot of a drone that is showing the P-band and the C-band sensor and the L-band sensor. This drone has just come back from Portugal. We're doing a study for a mining company. I'll tell you a little bit about it just now. So again, we're looking at moisture, shallow voids, deformation, biomass, greenhouse gas. So we've just acquired some sensors for greenhouse gas detection, but on water treatment plants. Because the best way of understanding what greenhouse gas are emitted from water treatment plants is to fly above them. No point putting a sensor on the floor. It's not very effective. So we are in discussions to be able to fly around water treatment plants. They create greenhouse gases and conduct the measurement on that. There are some legislation, that's European legislation, that the UK is not party to at the moment, but it still recognises it as one of the ways to monitor and control mine water treatment plants in terms of greenhouse gas emissions. The user cases, well, it's used for all sorts of things, mining, slope failure, drainage is a key one, climate resistance, and again biodiversity studies, I think will just become absolutely commonplace on all projects. Drought, soil erosion we can measure, and often in projects you'll get a combination of these things. So once you've collected the data, you can draw a number of inferences from that data on different types of user cases. Burrowing animals I've talked about. Archaeology is another area you get involved in. We have a couple of archaeology companies within RSK, and they look to us to do a flyover of a particular site and see what's buried in there. You can do it by GPR like they do on the telly, giving it that. We've got a better way of doing it. And it can cover more ground, and it's very accurate as well. And in terms of interpretation, it's not the squiggly line stuff that you get with GPRs, it's a bit more than that. And this is what it looked at. So, this is a project that was done in Finland. It's part of the Golden Ram funded project by the EU on strategic minerals. And the warm colours, so this is a tailings storage facility. Great heat at the moment in terms of safety on TSFs. One of the critical factors of TSFs is understanding where there's a potential in terms of failure. Often failure is driven by excessive soil moisture and slippage. And this is what these sort of things are picking out. This was a resolution of between 10 and 20 centimetres over 50 hectare service, pretty big bit of ground. We use CNL and P-band. And we can achieve tomography on this. And what's meant by tomography here is that as the P-band penetrates through, we can individually section the top 20 centimetres, the middle centimetres, and go down. So we're getting levels of soil moisture within that band as well. It's new work, but it's coming up trumps at the moment, and we're quite confident. There's a job that we did. It started off, phase 1 started off with a coal authority. Phase 2 we've just finished for the Welsh Government. So this is on category D spoil tips. You can see it outlined in that sort of black line. And what we're showing here is soil moisture greater than 40%. So this was done in 22, it's a satellite pass, yeah? So this is what it looked like November 24. We did it seasonally. And this is what it looks like in May 2025. So you're getting a really good model of what's happening on this spoil tip, yeah? The lines that you shown across it are where a sister company of ours called Binnie's is doing some drainage planning and remediation to help drain this particular spoil tip. And quite obviously, for them to have this level of data before and after they've done their drainage is a pretty good, useful way of doing things. So we're looking to do another trial using a UAV, not a satellite, towards the end of this year. This is a job that we've just finished. So it's a quite difficult terrain. It's forested. This company wanted some quick results in terms of they had some idea there was some quartz veins crossing the lease areas. They were picking up soil moisture. They were worried that that would impinge on their planned layouts for their pre-fees in terms of where they put the TSF and things like that, and where they were locating some of the facilities. So we've flown across it. We'll pick up the quartz veins. We'll pick up any soil moisture that's associated with that. And they've also, on the back of that, also said, can you start looking at and delineate or trying to delineate the pegmatites within the area as well. So we don't know whether we can do that yet, but we'll try it. We'll have a look at the data. It was out of scope. We've got the data anyway, so we'll have a look at it, yeah? And again, there's the drone being flown off or landing. Portuguese customs managed to want to keep it as we left. For that, you know, taking drones in and out of country is a delicate matter. Just a couple of slides on AI analytics. We are a partner of a company called Purple Transform, who are absolute fantastic with sort of AI and analytics and data scientists, very clever sort of guys. They're an award-winning company. What happens here is that this data is a large body of data, several hundred gigabytes in some degrees, yeah? So you need some power behind this to pull out data anomalies, the relationships within the data, and really get some clear understanding of it. So we use, we're partners of, certified partners of Purple Transform, so we can use their AI platform, which is called Sight, and it enables us to squeeze that data even more. One other thing about this, just quickly, is cameras. In the world of AI, it's all very clever and stuff, but one of the features that surprises me more than anything else is that they are able to take conventional security cameras and using AI and machine learning identify objects. And an object can be a car, it can be a person. And because of that, they can set up warning signals of saying that person's not allowed in that area, he doesn't belong to that company because that person, that object, isn't wearing the right PPE. So it's a person that shouldn't be there. So the stuff you can do with conventional cameras and combining with AI, machine learning is quite incredible. And that, thinking along a plant-based side, where we can set things up and we want to do some trials whereby things that are always happening on plant that people are trying to observe all the time. Overspilling on tanks. So we have cameras. If we do some machine learning, we'll automatically be able to detect and alarm and send a photograph that tank 4 is overflowing. Or blinding of screens would be another one, perhaps. Or things that always happen, like on transfer points between conveyors. They're always spillage. So again, we set cameras. We do machine learning to what spillage looks like. Alarm it, send it off. Comes on your phone. Oh, that bloody conveyor again. Send somebody out there quick. Instead of relying on individuals to do it, yeah? So again, it's squeezing the data that's available. So in summary, we're about data acquisition in many different forms. We have experience in terms of how to handle that data and then squeeze some value out of that data in terms of rapidly moving it into information. And yeah, that's us really. We're in one of our key areas is in the monitoring area and remote monitoring. And it's an exciting and fast-moving area. Thank you very much.
Yeah, in terms of the multi-band, and I was wondering how it was affected by altitude and whether it affects anybody who, say, walks under it, personnel or anything like that?
No, I don't think so. No, it doesn't. No, it doesn't, no. Look, I mean, they've gone through critical cases. It's a fairly common approach in terms of, these are radio waves, effectively, and different wavelengths, yeah? Right. So it's nothing that's spectacular about it at all. It's just that you've got to pick out the sort of frequencies that you want in terms of a radar, yeah? So no.
So in practice, it could be perhaps used from a satellite?
Yes, it's one of the same thing. It's just that with a drone, you're not confined to just L-band or certain bands that's affixed to the satellite. We can choose which bands we put on our drones. So it gives us much more flexibility in terms of how we want to approach that project for that client.
Okay, thanks.
But yeah, they're intrinsically safe. Yeah. Thank you.
Thank you very much. Brilliant, right. Well, that brings our symposium to a close. I mean, just I suppose as a quick overview, the safety topics. Thank you very much for all of those. It's of course, you know, you hear about how you dig a mine and all of that, but of course there's so many more safety processes and fire risks and things that you need to take into account, which they never tell you at university. And it was really interesting, of course, for all of the talks again on geotechnical. Great to have Angus back talking about hydropower again. Also all of the remote sensing, which are constantly developing area. So thank you very much, David. And of course, really interesting to hear about active exploration actually going on in the UK as well. And it was also really good just to get an overview of some of the developments going on here in the Northeast. And yes, I think Phil's quick thing at the end by saying Team Northeast can succeed is perhaps a motto of the day. In terms of other succeeding things, I've just been informed, and I double-checked, David, but our institute has won Local Society of the Year from IIMM. So there we are. We'll have to do an official announcement, but there we are. So, Of course, thank you very much for all of our volunteers who have helped us get that far, and of course everyone who actually comes along to attend our events as well. So brilliant. So that's a fantastic way to round things off, and I think with that, yes, the team North of England can definitely succeed. And I wish you all on your merry way back to wherever you need to go. But thank you very much, and I do hope to see you all again. And just one final mention again, thank you very much to ABMEC as well for partnering with us over the last 2 days. So all of your contributions are very gratefully received. So a round of applause for ABMEC.